seen syllabus copy also. Okay, just I am revising here. This is a syllabus copy. You will be knowing that there are two stages, that is a paper 1 and paper 2, right? In this paper 1 we have a syllabus like 50 plus 50 and 100. Okay, and this general studies and intelligence and reasoning, this will be 50 marks and 50 questions. And general awareness 50 marks and 50 questions. And later after that, a particular to our engineering branch, that is civil engineering branch, there we will get 100 questions, 100 marks. Okay, and here very briefly they have explained what syllabus is there here. That is building material estimation, estimating, costing, valuation, surveying, soil mechanics, hydraulics, irrigation engineering, transportation engineering, environmental engineering. And they have made a separate part in that one: structural engineering, theory of structures, concrete technology, RCC design, steel design. Okay, this is a brief that for paper 1 brief syllabus. And for paper 2 the same syllabus but it is blown up. That is building material. They have clearly mentioned what all you need to read in building materials, and in estimation and costing also what all you have to read. Like that we have this one: surveying, soil mechanics, that is geotechnical, hydraulics, that is FM, irrigation, and inside hydrology is also merged, transportation engineering, and environmental engineering, where both water supply and wastewater is there, structural engineering, in that one theory of structures, concrete technology, RCC, and steel. Okay, it is somewhat a very lengthy syllabus. Actually, in the northern part of India, the students are very used to this syllabus. Okay, they already know because every year more than 300 posts they will call in SSC JE. Every year it is. It's not like this time they are calling. No, every year they will call. Therefore, this syllabus almost it is the same. Okay, therefore they are very used to this one. But if you are preparing for first time, then go through the syllabus properly. And after that I have made a plan that I have already shared with you. This is our plan. Okay, because we have very less time to prepare, because we have started our preparation in the month of August, that is the 7th. Today is the 7th August, and I have planned like 1 week for one subject. That is structural engineering 1 week, soil mechanics another next week, environmental, irrigation, transportation, and surveying and fluid mechanics we have to complete in 1 week. Concrete technology and RCC we have to complete it in 1 week. Then we have building materials and building components, and estimation and costing, intelligence and reasoning. In notification they have mentioned that in the month of October exam will be conducted, that paper 1 will be conducted. Okay, in the month of October, but we don't know exactly what date they will start. But usually if I consider October 15th, middle of the October, then till that we will be completing our syllabus. Okay, and if this extends, this date is extended, the paper 1 date extends, then we have enough time so that we can practice more questions. And even meanwhile I will conduct some exams also, some tests also, so that you can participate in the tests. Okay, this is what my plan. And it is very difficult. Yesterday I was making this plan. It is very difficult to cover the entire structural engineering subject in this 6 days. Like that soil mechanics also, in the entire soil mechanics covering in 6 days, it is very very difficult. That too 2 hours a day, 2 hours a day, it is very difficult. That's why the one thing is that, but for me it is a 2 hours, because I have to cover in 2 hours per day. But you will be having one full day, right? Most of you, if you are not working, then most of the time you will be having a full day. Then in that full day you have to plan. Therefore I will be sending lot of materials in the group. You can prepare them and ask doubts meanwhile. But this will be 2 hours. Within the 2 hours I have to cover the syllabus whatever it is mentioned in the copy, right? And here I have listed very small this one content, but they have elaborated, it's not a matter. Elastic constants are there, means before that there will be many things we have to read. One very important thing about syllabus is one very important thing about syllabus is they have mentioned structural engineering. In that one they have said theory of structures, task. In Karnataka we will call it as a essay, structural analysis. In northern part they will call it as a task 1, task 2 they will call theory of structures. Okay, theory of structures and essay 1 and essay 2 are not same. In Karnataka, we have strength of material or mechanics of material. After that, we will be having this structural analysis 1 and 2. But in the northern part of the this India, where we will be having TOS 1 means it is SOM plus SA1, and TOS 2, sorry, this TOS 2 is your SA2. TOS 2 is SA2. That's why in syllabus you can see here they have mentioned theory of structures. Okay, where it is theory of structures they have mentioned here. Theory of structures they have mentioned. It doesn't mean that only strength of material or only structural analysis is there. No, and even they have mentioned directly elasticity constants. Right? It doesn't mean that we have to read only elastic constants. No, we have to completely cover some. And after that here from some here beams and all, from here you will be getting SA1 part, a little bit of SA1 part. Of course, no need to study SA2. That is your AIS. Nowadays you can call it as a analysis of indeterminate sorry ADS, analysis of sorry, correct, IS, analysis of indeterminate structures. SA1 is ADS, analysis of determinate structures. This we have to cover. Along with that we have to cover some. Okay, this example I have given for this theory of structures. Like that, if you go for another subject like irrigation, here they have mentioned irrigation, but most of the parts here come from hydrology also. Hydrology. Okay, the conclusion is you have to see only headings and don't see the syllabus. And see the heading, don't see the syllabus. Why? Because they will ask everything related to surveying to diploma level. Correct? And soil mechanics, it is said, means geotechnical 1. And of course we will be seeing the syllabus, but you prepare everything related to soil mechanics. Like that we have to prepare. That's why in my syllabus copy I have made only points so that I can cover all the things. Right? This is all about syllabus. If you have anything to ask about syllabus, you can ask. Do you want to ask anything in syllabus? Just I will give 1 minute. Any doubts? Sure. We will go to the next one. Hope the syllabus is clear, right? Okay. Okay. Now slowly we will enter into the syllabus theory of structures or strength of material or mechanics of material. Okay. In this one first chapter, usually we have called simple stresses and simple strains, but here in the syllabus they have mentioned elastic constants. Elastic constants. Okay. Now in elastic constants are simple stress and strain, simple stress and strain, where we will be covering stress and strain, their types of stress and strain. Then after that, stress strain curve and important terminologies. Then after that, equations related to Hooke's law, Hooke's law, deformations. After this, we will be studying elastic constants. Elastic constants. In syllabus, they have mentioned only this one, elastic constant. They have mentioned, but we have to study the other things also. After elastic constants and introduction to temperature stresses. Temperature stresses. Okay. Then after that, we will solve problems or objective questions. Objective questions. Right? We will be solving objective questions. This is what our plan. Okay. Now, every day we will be starting our class at 8:30 sharp, and 8:30 to 9:30 or 10 o'clock I will be explaining concepts, only concepts. Okay, ಸುಮ್ಮ ಕುತ್ಕೊಂಡು ಕೇಳಬೇಕು. Don't ask any doubts in this one. Okay, I know your mindset, because students where exactly they will be getting doubts, that I will be addressing in between. And after that, you make a notes along with my writings. Okay, along with this one you make rough notes. Okay, no, don't make a very fair notes while explaining this one. Just make a rough notes. Okay, rough notes. And after that, 10 to 10:30 we will be going through objective type questions. Okay, see, this concept is not important. This objective type questions, solving that objective type questions and answering is very very important. Sometimes what I do, I will give very less time for concepts and explaining that one, and I will give more time to the objective type questions. Less time to concepts and more time to objective type questions. When I solve objective type questions, you are free to ask any doubts. Free to ask any doubts. Okay. Okay, meanwhile, while explaining also you can ask some doubts. If you are not following, or if it is too fast, those things you can just convey me, and we can go slow, or otherwise we can revise the concepts. If it is not understood anything, there only you can stop and ask. Okay. And to cover the entire syllabus within a short time, that's why I have made some pdfs. I have collected some pdfs. I will be explaining the concepts in the pdf itself, and that pdf I will be sharing in the group. Okay, now we'll go by this pdf. Any doubts? Would you like to ask anything? Okay. Yes, we will go ahead. The first one is a stress and strain. See, stress means what? Stress is the internal resistance offered by the body. Internal resistance offered by the body. This is the internal resistance. Means something is there, some body is there. I will pull it in one direction, but instantly there won't be any deformation here. Instantly there won't be any deformation. Means this is resisting inside. There is a resistance built inside. Why? This is not deforming. That's why the internal resistance offered by the material is called as stress. Okay. How we will measure? We will measure it like P by A, force applied per area. Here you can see the force. Here you can see this is the area where the P is applied, and internal resistance, that resistance will be inside the body, that you can see here. Okay, na? Then the stress is equal to P by A. Then P unit is Newton and area unit is meter square. Therefore, the unit of stress is Newton per meter square. First time it is introduced by a scientist called Pascal. Therefore, 1 Newton per meter square is called as 1 Pascal. 1 Newton per meter square is called as 1 Pascal. Now, if you have kilo Pascal, then that kilo means 10 raised to 3, and that Pascal is Newton per meter square. Right? Like that, mega means 10 raised to 6. Then again you have a Pascal, therefore 10 raised to 6 Newton per meter square. Then giga 10 raised to 9, then 10 raised to 9 giga per meter square. Okay, these are all the notations we are using. Okay. See here, once again, I will come out of this one and I will give some idea. See, we are preparing for paper 1. I have gone through many previous year question papers. From that, I got some conclusions that paper 1, it is completely diploma level. Diploma level. Diploma level means you just 10th pass, 10th pass and entered into engineering. That level questions will be there in the paper 1. When you pass this paper 1, when you go to paper 2, there the questions and problems will be somewhat difficult. This I will call it as a BE level. Okay, that's why whenever you are studying for paper 1, then study elementarily. Okay, that is what is giga, what is mega, what is kilo. These all things you have to understand. Of course, these are all very small things, but you will stuck in the small things only. That's why. Okay, and this is just a small problem. You can solve that one. The resultant of the internal force for axial loaded member is normal to the section cut perpendicular to the axis. Means they say that the resultant will be, means there will be many forces in the bar. The resultant of all these bar is one arrow, and this arrow will be perpendicular to the surface. When this is perpendicular to the surface, see, this is the body and this force is perpendicular to the surface, then we will call it as a normal stress. Normal stress. Another name for normal stress is direct stress. Another name for normal stress is direct stress. Okay, that they have said here. Okay. Then we have two types of stresses now. The one is tensile stress and another one is compressive stress. Tensile stress means the body is pulled by equal and opposite forces. This is one force, this is one force, equal and opposite forces, the body is pulled. Okay. When we pull the body, there will be elongation in the body. There will be elongation in the body. Then compression force means the body is pushed in both in a equal with the equal and opposite forces. When we push the body will compress. This is tensile. Here they have said it something like stress is greater than 0 is tensile. Stress is greater than 0. Why? Because we always assume tension means positive. Tension means positive. Positive is means what? Positive is always greater than 0. This stress is greater than 0. That is positive. Then compression means the stress is less than 0. That is compression, or compression is negative in sign. Okay. Value will be same. Only we are seeing the negative and positive based on the sign conventions or nature of the force. Okay. Right. Okay. This is your compressive force. This is your compressive force. Okay. Then another force comes shear force. Shear force means this is the body. You have this section, but this time the force is not compressing or not expanding. It is applied in something differently this way. Okay, this force is applied so that at the end the body will be cut like this. Okay, it's like scissor. Okay, this is like a scissor and it will cut the body. When it cuts, you will be having one force in this area and another force in this area. Then if this force is F and this force is F, and the area whatever that is there here, that is A, then again you will get a P by A is a force, that is a stress. Such stress is called as shear stress. Okay, shear stress, another name for shear stress is tangential stress. Another name for shear stress is tangential stress. Many times they will ask this one. Tangential. Why tangential? Because if this is the body, this force is applied tangential to the surface. This is the force. Very tangential to the surface it is applied. Okay. Now we have studied about stress. What is a strain? Strain means the response. Stress is stimulus. Stimulus. Okay. And strain means response. Okay, response. Then in tensile, I already explained, that is change in length. Earlier the body was like this was the body, and I apply the force, then it elongates this much. That elongation is called as delta L, and the original length is L naught. Then my strain will be change in length to the original length. Okay, how to get a change in length? Changed length, actually not actual, changed length is L plus delta L, you can call. This is tensile. The same way compression will be there, but here we will be considering negative sign. Okay, na? See here, very interesting. Shear strain is something different. Shear strain is completely different compared to other strains. Why? Because shear strain is just an angle. Always remember, shear strain is not change in angle by original angle. Okay, this is a very important. That's why many times they will ask in examination this question. If I apply force like this, then the body will bend like this. Correct? Now, there is no increase in the length, increase in the breadth. Just there is a distortion. This word is called as distortion. Distortion andra change in angle. Here angle is changed. Okay, this itself is a shear strain. This itself is a shear strain that they have indicated here, you can see. Then if I consider this angle, then opposite and adjacent, if I write tan, that distortion is equal to opposite by adjacent, then tan theta is very small, therefore tan theta is equal to theta, that is delta by L. This is your shear strain, that is your shear strain. delta L by L. It is not change in length by original length. Okay, remember this one. Then, what is the unit of strain? Whatever the strain it might be. In earlier case, that unit is mm. Change in length is in mm, and original length is also in mm. Therefore, cancel, and this is mm per mm, no unit. But sometimes they will express the unit like mm per meter. Okay, this is just a foolishness. We will be stuck with this equation, this unit. See, mm per meter, mm per meter. Actually, meter will cancel, but still they will call strain as a mm per meter. Why? Because it is very easy to understand. If the bar is 1 meter, then it extends 1 mm, means 1 mm per meter. That is your mm per meter. Okay, they can tell. And some textbooks or in some conventions they say that strain can be expressed as percentage. Okay, strain is expressed in percentage. Okay, unitless, mm per meter, percentage. These three are units of strain. Okay. True stress, true strain. For diploma level, this won't be there. Just I will introduce, these equations are not required now. I will just introduce the true stress and true strain later when I explain stress strain curve. Okay, this is not required. Later you can go through. Okay, some problems will be there. Now Hooke's law. Okay, we are all very familiar about Hooke's law. We are all very familiar about Hooke's law. That Hooke's law states that stress is directly proportional to strain. That is, normal stress is directly proportional to normal strain. This is one way. And another way, shear stress is directly proportional to shear strain. Okay, you can call in the both the ways. That is, normal stress is directly proportional to normal strain. Then you will get this equation. Then shear stress is directly proportional to shear strain. Then you will get this equation. Okay, the coefficient E is called as modulus of elasticity in this case, and G is called as modulus of rigidity. Okay, interesting. Okay, now we got two different terms, that is E is a Young's modulus and G is a shear modulus. I will explain this one here. See here, we all know that stress strain curve is very important because here we will understand many things. What is this axis? This axis is strain and this axis is stress. This is P by A, this is delta L by L. Delta. If I consider a bar, then if I apply stress sigma here, then the bar will start expanding. Okay, the bar will start expanding, but initially as I apply this much of stress, then it will yield this much, means the bar will go in this direction, right? This much. Okay, later if I increase the load, means increase the load, the strain is also increase the load, strain will increase the load, strain will increase. This will happen up to one particular point. What happened? As the stress increases, strain increased up to some particular point. That point is called as proportionality point. Proportional point. Okay, that is a P. And if you remove the load, then it will come back within the same line. Look at here. If I remove the load, this will come back in the same line to the origin. If it is coming back to the same line, means look at here, while going it went upward direction, and if I remove the load, then it comes in the same path. Then that material is called as elastic material. That material is called as elastic material. Okay. Now this that regaining its original shape will happen up to particular point, this point. Therefore this point is called as elastic point. Elastic point. Practically, you can note it down. Practically speaking, proportionality point and elastic point both are same. Both are same. But theoretically, these two are something different. Always E will be farther than the P. That is above. E will be above and P will come first. Okay, this is theoretical. Right? Now you have got this relation, that is stress is directly proportional to strain. Okay, stress is directly proportional to strain. When I say stress is directly proportional to strain, then stress power is 1 and strain power is 1. Power is 1 means they are linear. They are linear. When they are linear and with elastic, therefore this zone, I will call it as a linear elastic. This is called as linear elastic or elastic zone. That is linear elastic zone. In linear elastic zone, in linear elastic zone, we have straight line. We have this straight line. Straight line is there means I can take a slope of this straight line. I can take a slope of this straight line. Then slope of the straight line, if I write this angle itself is your Young's modulus. That angle is Young's modulus. Then define this angle as opposite. Opposite is this one is opposite, that is your stress, and this one is adjacent, that is your strain. Therefore, I can call E is equal to stress by strain, or here only you can write sigma is equal to strain times Young's modulus times strain. This is Hooke's law. This is Hooke's law. Right? Any doubt? These minute things are very important, because while framing questions, they will consider all of them and they will frame the questions. Okay, it doesn't mean that just they will ask what is a stress strain curve, or otherwise what is Hooke's law, what is elastic material, what is linear elastic. No, these are all things you should know before answering any theoretical questions. Now, very interestingly, if I increase more stress, if I increase more stress than this point, then the curve will go in this direction. Okay, curve will go in this direction and there will be decrement and again it will increase. Okay, this will take this shape. I'll take just below to this one. We understood clearly, what is this stage. We were here. If I increase more load, then it will take another path and it will decrease, then again it will take the path. Okay, here it will break. The material what we considered here, if I increase the load, then it will break here. Okay, that will break. Then this is called as a breaking point. This is breaking point. Now this is ultimate, therefore ultimate point. And load corresponding to ultimate point is called as ultimate load, sigma y, and load corresponding to this breaking is called as breaking load, sigma b you can call, right? And here we are seeing, okay, here we are seeing, here we are seeing 2 points. one point here and one point here. Okay, these two are upper yield point and lower yield point. This is upper yield point and this is lower yield point. Okay, this zone is called as plastic zone. Okay, and from here this is strain hardening. This is strain hardening because the material is again taking the load. That it starts taking again the load, therefore it is strain hardening. Okay, now after that, after when it reaches ultimate point, later the stress will go down, but actually it should not happen, right? The stress going down should not happen. It always should increase, right? It always should increase. If you consider this graph, then that is called as a true stress strain curve. True stress strain curve. Then if you consider this one, that is called as a nominal stress strain curve. Nominal stress strain curve. Okay, in true stress strain curve you will consider actual area. Okay, in nominal stress strain you will consider original area. This is very very important. Here actual area and here you will consider original area. Instead of, see here, this was your bar. When you pull this one, then it will reduce like this. Correct? It will reduce like this. Here the area is AC. That is corrected area or actual area. But this area is A0. Correct? Now, if you consider this area, that is your nominal original area. If you consider this area, a small area, that is your true stress strain. This is ultimate, and they will definitely ask a question on this one related to this concept, that is what is true stress strain and what is nominal stress strain, right? Now we'll come to volumetric strain. Volumetric strain means, let us consider a body. This is a body subjected to three-dimensional stresses, correct? Sigma x, sigma y, sigma z. When I consider a three-dimensional stress system, then it will change its volume, correct? It will change its volume in this direction, in this direction, in this direction. No, it will change its volume, correct? Okay. When it changes its volume means what? Earlier volume is V and later it becomes V plus delta V. Okay. This change in volume occurred, right? This change in volume compared to original volume is called as volumetric strain. Is called as volumetric strain. Correct? Always remember this volumetric strain. This equation is very important. I'll write again that this is a body. If this body is pulled in this direction, then this is sigma x. And what about epsilon x? Epsilon x is delta Lx by Lx. Change in length in x direction by original length in x direction. That is sigma x. No, sorry, sigma x is in this direction. I am writing this one. Now, if I write in the same direction, that is your sigma y, if I apply, then change in strain in y direction is equal to change in length in y direction by original length in y direction. Like that, I can write it in the z direction also. These two and this z direction strain, all three, look at here, see epsilon x, epsilon y, epsilon z, all three together is also volumetric strain. Means volumetric strain is nothing but strain in x direction plus strain in y direction plus strain in z direction. Plus, very important, this is plus. Okay. Now one word comes here, dilation. I'll just explain you this word dilation. Dilation means, I think in childhood you have played this game. You will take a small balloon, small balloon you will take. You will tie this one here. Then inside air will be there. Then you will just press that balloon in your hand. Okay, this is your thumb, and you will just press. Then that balloon will become like this. Then if you press in this direction, it will expand in this direction. Press in this direction, it will expand. Like that the balloon will expand in many direction, but volume will be same. Correct? Volume will be same. If you press this direction, it will take in this direction, but it will increase in other direction. Press in this direction, then it will take this shape and it will increase in other direction, but volume will be same. That property is called as dilation. Okay, where three-dimensional volume will be there and that pressure applied will be considered. Okay, this is your dilation. Right? Then after that we have a three modulus, that is Young's modulus is nothing but stress by strain, shear modulus, that is also stress by strain, and bulk modulus, that is also stress by strain but volumetric strain. Separately I will write it here. Young's modulus, normal stress by normal strain, shear modulus, shear stress by shear modulus, then bulk modulus, bulk stress or delta P divided by volumetric strain. Okay, these three are very important. These three are called as elastic constants. These three are called as elastic constants. Now separately I will write it here. Separately I can write here. Wait. Then I have got elastic constants. E is equal to stress by strain, stress by strain. G is equal to shear stress by shear strain, and K is equal to stress, again that stress or delta P divided by volumetric strain. These three are elastic constants. Along with that we have one more elastic constant, that is called as Poisson's ratio. Poisson's ratio. Poisson's ratio is denoted as mu in some textbooks. In some textbook they will mention it as 1 by m. Poisson's ratio. Okay. Poisson's ratio is lateral strain by longitudinal strain. The meaning of this one is, if this is the body, you pull in this direction, when you pull this one, then it will elongate in this direction and it will contract in this direction. See, this contracts and elongates. This is your real body. Here contraction and here expansion. This this gives strain in longitudinal direction. This will give strain in lateral direction. Then lateral by longitudinal is called as Poisson's ratio. It's called as Poisson's ratio. Okay. Now we have very important equations. By heart these equations. E is equal to 2g into 1 plus mu, and E is equal to 3k into 1 minus 2 mu. Okay. And E is equal to 9 kg divided by 3k plus g. These three are very important equations. They have write it in single box, but you remember this one. Okay. Means, look at here. We have a three equations. E is equal to, once again, 2g into 1 plus mu. E is equal to 3k into 1 minus 2 mu. Okay, these two equations are enough. If you analyze this one, then if you know E and G, you know, G and mu, you will know E value. If you know E value and mu value, then you can calculate K value, right? Means we have E, G, mu and K. We have four parameters. Minimum two are required. Two are required to solve other two. Other two. This condition is, I can write it like that, minimum two elastic constants are required, are required for what? To solve isotropic and homogeneous bodies, material, homogeneous material. Now interestingly, this number is very important. Minimum two elastic constants are required, correct? Now minimum 9 elastic constants are required to solve orthotropic ortho orthotropic body, orthotropic homogeneous body. Then here 9 is very important. Then another statement you have to remember, that is minimum 21 elastic constants. Elastic constants are required to solve anisotropic anisotropic homogeneous body. This you remember one question fix. Correct? Isotropic 2, orthotropic 9, anisotropic 21. Okay. Now Poisson's ratio I explained, and this table, as much as possible, just you by heart this table. From this, you will get some idea what is the meaning of Poisson's ratio. That is, steel will have Poisson's ratio 0.25 to 0.33. Cast iron will have 0.23 to 0.27, concrete 0.2, rubber 0.48 to 0.5, cork 0, and novel foam body will be negative. See here you have one scale here. This is the scale. Maximum is how much here? Out of all these, maximum is 0.5. That I will write 0.5. And minimum is how much here? Minimum is nearly 0 is mentioned. That I will write 0. 0 to 0.5 is your scale. 0.5 is what? 0.5 is rubber, water, oil. Okay, these are all having Poisson's ratio 0.5. 0, cork, diamond, right? Very hard material, very hard material. Then coming to here, 0.25 is how much? This is in between 0.25. 0.25 is how much? Steel. Steel is not hard like a diamond. Steel is not soft like a water. Therefore, it is in between. That is in between. Then concrete. Concrete is where it will come. It will be brittle. You consider like a brittle. This concrete is brittle. Cork is brittle. Diamond is brittle. Hard means brittle. Concrete is brittle. That's why it is coming this direction, concrete. Correct? Now another one was there here, rubber 0.48. If you take some aluminum or copper, then they will come this side. Okay, just you remember this scale so that you can answer any questions. Okay, this biaxial stretching is not required. This we already studied. That is, stress is directly proportional to strain. That is strain, Young's modulus into strain. Then strain is delta L by L, and this is E, this is P by A. From this, if you get delta L value, that is your PL by AE. That is the formula, PL by AE. Elongation of composite bodies. These in paper 2 we will consider. Okay. And in problems, if we get anything, we can solve also. This derivation is not required, but the equation is very important. What is that? Huh. Tapering bars. If the bar is like this, having this diameter d1 and diameter d2, then if I apply some force, then it will also elongate. When it elongates, that will the value of that elongation delta L is equal to 4 PL by pi E d1 d2 by E d1 d2. Just we have to by heart this. Okay. This tapered bar. Now, due to self-weight, look at here. If there is something steel bar or some mass is there here, and we have not applied any force to this one. Very interesting. We have not applied any force to this one, but still it will deform. It will deform by its own weight. Its own weight it will deform. That equation is this one. That is, weight of this body is W, length of the body is L, the area of this body is A. Then you will have WL by 2A. Okay. And thermal temperature stresses, thermal or temperature stresses, that stress is equal to alpha into delta T. Delta T is change in temperature, or if you want delta L by L is equal, this is delta L by L, alpha into delta T. Okay. Therefore, change in length due to temperature is L alpha T. L alpha T. Okay. And now stress stress due to temperature is alpha TE. Alpha T. These problems are for paper 2. Okay. Now, creep. Just you remember the definition of creep. Creep means it is a time dependent elongation. Time dependent elongation means, let us consider, you have one plastic bag, like this one plastic bag is there. Inside the plastic bag you put one stone. Inside the plastic bag you will put one stone. After 1 month, after 1 month, if you see the plastic bag will be expanded. No? You have not increased the load. You have not increased the load, but it will expand. Why this expand? Because of constant load. Constant load. This expand in time. Therefore, this strain is time dependent strain. That is nothing but creep. Creep means time dependent strain. Okay. Now, stress strain curve already explained. That is your elastic strain, the linear strain. Then after that, here small increment will be there, ultimate, and fracture. You can go through this one. And those definitions are written here. Okay. Now there are some important diagrams for stress strain curve. This is called as linear elastic. Why? Because this goes like this and it breaks here only. This is only the breaking point. Breaking point. This is a breaking point. Then that material is called as linear elastic material. Okay. And this is a linear and this is a plastic. Therefore, linear plastic, sorry, linear elastic and plastic. Okay. Now, this plastic is what? Perfect plastic. Why? If it is horizontal, then it is a perfect plastic. This is perfect plastic. I will draw it here in some other direction. Now look at here. This is elastic. This is perfect plastic. Perfect plastic. This is elastic perfect plastic. Elastic and perfect plastic. Now this and this is not perfect plastic, but this is elastic. Therefore this is elastoplastic. Okay, these things. Now look at here, very interestingly, as I increase the load,
It's 9:29 p.m. You don't have any notifications at the moment.
Mallu, okay. Mm, wait. As we increase the load here, the strain also increases. If I decrease the load, it will decrease, right? Means within the elastic limit, this up and go will be in the same line. Up and go will be in the same line. Okay, if I go beyond that in this direction, then if I decrease, it will come in this direction. Okay. Now if I increase in this direction, it will go up to this point, it will go. Then beyond that, it will go like this. Then if I decrease the load, it will come. Then it will go like this. Then it will come. Okay, such things will happen. Even sometimes it will happen like this and this way. Why? Because this small portion is called as plastic. Then after that, it will be, means this much is a plastic and this much is a elastic. Correct? Okay. If I draw that diagram in a different way, look at here. Okay. Now in this case this is elastic and this is plastic. Can you tell me why? Why? Because the material yielded how much yielded? This much yielded. Out of this much is regained. This is regained. Therefore that is elastic. This much is not regained. This is not regained. Therefore that is a plastic. If the material goes like this and breaks, here only it breaks, then this is elastic and this is plastic. See here, both are completely opposite. It breaks here, but this comes back. No, this we have to remember. Linear, elastic, plastic. That what I shown here is here. You can see the material goes like this, then comes like this. This is residual strain. Residual strain means plastic, and this one is elastic. Okay, and it goes like this and comes in that way. Then that is elastic strain. But goes like this and breaks somewhere. Then elastic. Then plastic. Correct? Okay, this is elasticity. Elasticity you can go through. Oh, this is not required. Okay, this much is a theory, that first day, that simple stress and strain or otherwise elastic constant. Have any doubts? Okay. If you don't have any doubts, then we will go through objective type questions. Okay. See here, one thing is, wait, these are from gate. Okay, the questions whatever I shared below this theory part, those answers are gate. See here, SSC when you are preparing 2000, sorry, 1999 to 2010, 2010 of gate and IES and UPSC questions will come into SSC, because nowadays it is upgraded. That's why 1999 to 2000 or 2010, no, 2005 tak, no, 2005 till 2005, the questions are very 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 basic level. Therefore, you can consider them for diploma level. Consider them as a diploma level questions. And gate questions you can consider them for paper 2 SSC. Paper 2 SSC questions, but not in very deep. But easy questions of gate will be tough questions of SSC paper 2. Easy questions of gate, IES, UPSC will be tough questions for SSC paper 2. This you can remember. And these the problems and these concepts you can go through later whenever you are free. But for me, I will consider this one mark questions for paper 1. Okay. Okay, go through this one. Now you can unmute yourself and go on answering or asking questions. Everything is permitted. Or any concept which is not understood, or if I want to repeat, that also I can suggest. Go through the questions. What is the first question? Answer.
Newton per meter square, sir.
Newton per meter
Any
square.
one of the
Any one of the above. The correct answer is, this is the correct answer, right? This is also correct answer. This is also correct answer. Only thing they have made is what? Meter square is there, mm square is there, and mm square. Newton badlagi kilonewton and Newton. Therefore, all are correct. D is the correct answer. D is right answer. Deformation per unit length. Change in length per unit length. Strain. Correct? Unit of strain. Option E. Mm per minute. Mm per meter. Option E of radian, degree per radian. Degree per radian. See, this is also unit of strain per cold. Okay, no unit is also right answer. Per meter is also right answer. Degree per radian is also right answer. Degree per radian when you apply twist or moment or this one slope. In that case, degree per radian, per meter, no unit is the units of strain. Strain is equal to delta L by L. Right? Now, when a body is subjected to two equal and opposite push and results, which of the result of which the body tends to reduce its length. Push apply ಮಾಡಿ length reduce ಮಾಡ್ತಾರೆ. Then the stress strain corresponding is the compression. Correct answer. Okay, this is pushed and length reduced. When a body is subjected to two equal and opposite pulls, okay, pulls F and F, which the body tends to extend, correct, then the stress strain induced is compression ಅಲ್ಲ, tension ಹೌದು, tension ಹೌದು, compression ಅಲ್ಲ, tension ಹೌದು, tension ಹೌದು, ಅಲ್ಲ, ಅಲ್ಲ. Therefore C is the correct answer. Body is subjected to two equal and opposite forces acting tangentially ಅಂದ್ರೆ ಹಿಂಗೆ tangentially across the resisting section, as a result of which the body tends to shear off ಅಂದ್ರೆ cut off ಅಂದ್ರೆ shear strain. ಎಲ್ಲೈತಿ D, shear stress, shear strain. Which of the following is proper sequence ಹೇಳ್ಬೇಕಂತ in stress strain curve. First proportionality limit, correct, ಅದಾದ್ಮೇಲೆ elastic limit, next yielding, next failure. Very good. Elastic first ಬರಂಗಿಲ್ಲ, wrong option. Yielding first ಬರಲ್ಲ, wrong option. Hooke's law holds good up to elastic limit or plastic limit breaking point ಅಲ್ಲ, plastic limit ಅಲ್ಲ, then
Plastic limit.
elastic limit. It is elastic limit, not plastic limit. Plastic limit comes in geotechnical engineering. Okay, ಇದು ಇಲ್ಲಿಲ್ಲ, ಇದು geotech. In strength of material, plastic limit will not come. Whenever a material is loaded within elastic limit, okay, within elastic limit, the stress is directly proportional to strain. Correct? Oops, la. Ulta kidan. The ratio of linear stress to the linear strain is called.
Poisson ratios.
Yes. Stress to the strain is like Poisson's ratio. Poisson's ratio is what? Lateral strain.
So B, sir.
Lateral strain to the longitudinal strain. Strain by strain is a Poisson's ratio. Here, stress by strain, no? Therefore, B, modulus of elasticity. Unit of modulus of elasticity is same those of. Nodana? Now, stress is equal to Young's modulus into strain. Unit of elasticity. Andre, we want unit of this one. Its unit is Newton per meter square equal to E. It don't have any no unit. Therefore, E unit is Newton per meter square. Its unit is stress, correct, but not strain. Pressure, correct. Stress, correct, but force alla. This is correct. Strain alla, force alla, pressure, correct. Stress, pressure, modulus of rigidity. Therefore, D is the correct answer. ತಿಳಿದಿಲ್ಲ ಅಂದ್ರೆ ಅಲ್ಲೇ ಕೇಳಿಬಿಡ್ಬೇಕು. Okay. Now, when a change in length takes place.
Sir, ತಿಳಿದಿಲ್ಲ sir.
ಇದು ತಿಳಿದಿಲ್ಲ? Okay. Because they are
So 13th question.
13th question, no? Okay. They are asking which stress. See, modulus of elasticity ಅಂದ್ರೆ ಯಾವುದು? E. Modulus of elasticity ಅಂದ್ರೆ E. ಈ ಸೇಮ್ ಆಫ್ ಅಂತ ಕೇಳಾರ, ಸೇಮ್ ಅಂತ ಕೇಳಾರ. ಸೇಮ್ ಅಂತಂದ್ರೆ ಎದ್ರ ಜೊತೆಗೆ ಸೇಮ್ ಐತಿ. ಫಸ್ಟ್ ನಮಗ ಮಾಡ್ಯುಲಸ್ ಆಫ್ ಎಲಾಸ್ಟಿಸಿಟಿ ಯೂನಿಟ್ ಏನಂತ ನೋಡ್ಕೋಬೇಕು. Modulus of elasticity unit andru ಒಂದ Newton per meter square andru ಒಂದ ಅಂದ್ರ this is Newton per meter square. Newton per meter square ಮತ್ತೆ ಎದರದ್ದು ಐತಿ ಇದು ಪ್ರೆಷರ್ದು ಸೇಮ್. Pressure unit is also Newton per meter square. ಮತ್ತೆ ಎದರದ್ದು ಅದ G ದು ಸೇಮ್. ಯಾವಾಗಲೂ ಯೋಚನೆ ಮಾಡ್ರಿ ಇ ಜಿ ಕೆ ಇವು ಮೂರದ್ದು ಸೇಮ್ ಯೂನಿಟ್ ನ್ಯೂಟನ್ ಪರ್ ಮೀಟರ್ ಸ್ಕ್ವೇರ್. ನಾವು ಆಪ್ಷನ್ಸ್ ಒಳಗಡೆ ಸ್ಟ್ರೇನ್ ಅಂತಂದನ ಇದಕ್ಕೆ ಯೂನಿಟ್ ಇರಂಗಿಲ್ಲ, ಇದಕ್ಕೆ ಸಂಬಂಧ ಇಲ್ಲ, ತಪ್ಪು. ಇದು ಅಂತಂದ್ರೆ ಇದು ಹೋಯ್ತು. ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಿ ಬಂದ್ರೆ ಫೋರ್ಸ್ ಯೂನಿಟ್ ಈಸ್ ನ್ಯೂಟನ್ ಅಂಡ್ ಎಲಾಸ್ಟಿಸಿಟಿ ಯೂನಿಟ್ ಈಸ್ ಡಿಫ್ರೆಂಟ್, ದೇರ್ ಫೋರ್ ಇದು ಐತಲ್ಲ ಅದ್ರ ಸಲುವಾಗಿ ದಿಸ್ ಈಸ್ ಗಾನ್. ಸ್ಟ್ರೇನ್ ಅಂತ ಬರ್ದನ, ದೇರ್ ಫೋರ್ ದಿಸ್ ಈಸ್ ಗಾನ್. Stress unit is Newton per meter square. Pressure unit is Newton per meter square. G unit is Newton per meter square. Therefore, this unit is also Newton per meter square. Therefore, D is the correct answer. Okay. Next.
Yes, sir.
When change in length takes place, strain is known as linear strain, lateral strain, volumetric strain, shear strain. This is wrong, this is wrong, because they have said length takes place. Okay, length takes place, linear strain and lateral strain. Linear strain. Why? Because lateral strain andre enanta perpendicular to the direction. Perpendicular to the direction. That is the lateral, but this is the linear. Another name for linear strain is longitudinal strain. Longitudinal strain. Okay. Next, change in length due to tensile or compressive force acting on a body is called as PL by AE. This is PL by AE. Okay. Modulus of elasticity for mild steel is approximately equal to by heart of modulus of elasticity E for mild steel. In textbook we will see 200 GPa. 200 GPa, which is near to that one, this one, but it is KMPa. K and this is nothing but MPa. MPa. M means 10 raised to 6. K means 10 raised to 3. 3. Both together 10 raised to 9. PA. 10 raised to 9 andra GPa. Therefore, this and this are near. D is the answer. Young's modulus may be defined as the ratio of
So C.
C. Linear stress through linear strain. Correct answer. Linear stress through lateral. No. Lateral strain. No. Shear stress. No. Correct? Young's modulus is C is the correct answer. Modulus of rigidity may be defined as the ratio of. Modulus of rigidity means G. D is the correct answer. Shear stress to the shear strain. Unit of Young's modulus is same that of stress.
Yes, sir. Same, sir.
Yes, true. Next, two bars of different material. This problem is okay. We'll solve this problem. Two bars of different materials and same size are subjected to same tensile force. We'll draw that one first. This is one bar, this is another bar, same size, means same area, same length, same size ಅಂತ. Then same material means this is also E, this is also E, same material. Subjected to same force. Okay. If the bar have a unit elongation in the ratio 2 is to 5, ಇದ್ರದ್ದು delta L 2, ಇದ್ರದ್ದು delta L 5, 2 is to 5. Then the ratio of modulus of elasticity of the two materials will be, oh sorry, different materials anta, different materials E1 and E2 materials are different. Then they are asking what is the this one and this one material ratio. Okay, delta L equal to P1 L1 by A1 E1, delta L equal to P2 L2 by A2 E2. Correct? Now that this is delta L1, this is delta L2. What all are same? We'll cancel them. Same, length same, L same, P same, L same, area same, area same. Therefore, delta L1 equal to 1 by E1, delta L2 equal to 1 by E2. They are inversely proportional. Therefore, if delta L is in the ratio 2 is to 5, then E will be having in the ratio 5 is to 2. Okay.
ಸರ್ ನಿಮ್ದು ಸ್ಕ್ರೀನ್ ಕಾಣುವಲ್ತು ಸರ್.
ಹೌದು, ಕಾಣುತ್ತಲ್ಲ. ಉಳಿದವರಿಗೆ
ಈಗ ಕಾಣುತ್ತೆ ಸರ್, ನೀವೇನು ಬರ್ದಿರೋಲ್ಲ ಅದೇನು ಕಾಣೋದು.
ಹೌದು, ಈಗ ಖಂಡಿತ. ಈಗ
ಹಾ, ಈಗ ಕಾಣುತ್ತೆ ಸರ್.
Now we have cancelled this one and this one, this one and this one, because sizes and forces are same. Right? Then ಈಗ ನಮ್ಗೆ ಉಳಿತೇನು ಡೆಲ್ಟಾ ಎಲ್ ಅಂಡ್ ಇ ಎರಡು ಉಳಿತು. ಅವೆರಡು ಏನದವ ಇನ್ವರ್ಸ್ಲಿ ಐತೆ, ಇಲ್ಲಿ ಇನ್ವರ್ಸ್ಲಿ ಐತಿ, ಇಲ್ಲಿ ಇನ್ವರ್ಸ್ಲಿ ಐತಿ. ಹಂಗಾರೆ 2 is to 5 is inversely 5 is to 2. Okay. Therefore 5 is to 2 is the correct answer. When a bar of L and diameter D is rigidly fixed at upper end, okay, rigidly fixed at upper end, hanging freely, the total elongation produced in the bar due to self-weight formula is WL by 2AE. Where is it? ಯಾರು ಹೇಳ್ತಿದ್ನ? This is my answer, but it is
B.
not there.
B.
B. But area is not there, no?
Option A, sir.
Option A. Why?
It shows only for one end is fixed, other end is free. That's the reason WL by 2AE.
Here, what is W? W is not weight of the material. W is not weight of the material. W is a density, because here it is written weight per unit volume of the bar. Correct? This we have to analyze. I will show you. See here. This is our bar. Okay. It has a area A, length L, and it has a weight W. If this is the case, then our answer is WL by 2AE. Okay, but they have given small w. Small w is nothing but weight by volume. Weight by volume. What is weight? Weight is weight. Volume means what? Area into length. Area into length. This is your w. Now I will consider my equation. which I know is WL by 2AE. This I know. I will multiply L and divided by L. Okay. What happens? Now W by this W by A and L becomes what? This W and A and L becomes what? Small w. Left out is L into L is L square divided by 2. Then this E. Therefore, delta L is this one. WL square by 2E is the correct answer. Where is that? WL square by 2E. That is B option. Any doubt?
No, sir.
The deformation of bar under its own weight is dash the deformation if the same body is subjected to direct load equal to the weight of the body. Easy.
B, sir.
B, correct, half. Right? Because we know that this is W L by 2AE, and they say that if the same bar is subjected to W weight ಅಂದ್ರೆ WL by AE, P ಬದಲಾಗಿ W ಬರ್ದೀನಿ. PL by AE is our equation. ಇದನ್ನ ಬರ್ದೀನಿ. ಈಗ ಇದಕ್ಕೂ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಇದು half ಅದ. ಇದು half ಅದ. Therefore the answer is half. Where is that? Half. Next. The elongation of a conical bar under its own weight is that of prismatic bar of the same length. ಇದನ್ನ ಹೇಳಿಲ್ಲ, ಯೋಚನೆ ಮಾಡಿ ಹೇಳ್ತೀನಿ ಅಂದ್ರೆ ಹೇಳ್ರಿ. ಎಲಿಮಿನೇಷನ್ ರೌಂಡ್ ಒಳಗೆ ಬೇಕಾದ್ರೆ ಮಾಡ್ಕೋ. Conical bar ಅಂದ್ರೆ ಏನಂತ ಹೇಳ್ತೀನಿ ಫಸ್ಟ್. Okay. Now look at here. Conical bar means this is conical bar. Okay. They want how much it will elongate if I apply P. ಸ್ವಲ್ಪ advanced question ಆಯ್ತು ಇದು. Right? For this one you can understand it like, if I complete this bar this way, this is one conical, this is another conical, and this is another conical. We are talking about blue line, therefore this delta L will be equal to one third of prismatic bar. One third of that. Okay, ಇದು rough ಇದು. It is not derived. Okay, it's rough. Then roughly you can consider one third. The length of the conical bar L, diameter of the base D, then the weight per unit volume W. It is fixed at upper end and hanging freely. Elongation of the bar under the action of its own weight B. You can tell. ಆಗಲ್ಲಿ ಮಾಡಿ ತೋರಿಸಿನಲ್ಲ, ಹಂಗ ಮಾಡ್ರಿ ಇದನ್ನ.
WL square by 6C. Option C.
Very good. ಬಂತೆಲ್ಲರಿಗೂ? Okay, because this is WL by 2
Sir, half, sir.
half ಆಗಲ್ಲ. Okay, wait. WL by 2AE ಯಾವಾಗಿದು? ಹಿಂಗಿದ್ದಾಗ ಸೆಲ್ಫ್ ವೇಟ್ ಇದ್ದಾಗ. ನಾವು ಕೋನಿಕಲ್ ಅಂದಾರ ಅವರು. ಕೋನಿಕಲ್ ಅಂದಾಗ ಏನಾಗ್ತೈತಿ, ಇದು ಒನ್ ಥರ್ಡ್ ಆಗ್ತೈತಿ. ಇದು ಒನ್ ಥರ್ಡ್ ಆಗುತ್ತಂದ್ರೆ ಇಂಟು 3 ಆಗಿ. ಈಗ WL by 6AE ಅಂತ ಬಂತು ಈಗ ಆನ್ಸರ್. ಬಟ್ ಇದು ಆಪ್ಷನ್ ಒಳಗೆ ಇಲ್ಲ. ಯಾಕಂದ್ರೆ ದೇ ಹ್ಯಾವ್ ಗಿವನ್ ಸ್ಮಾಲ್ w. ಸ್ಮಾಲ್ w is nothing but weight by volume. Weight by volume means weight by area into length. Area into length ಬೇಕಂದ್ರೆ ಇದಕ್ಕೆ L multiply L divided by. Then this W A L. becomes small w. Then 6 as it is, E as it is, L into L is L square. Therefore, this is your answer. Okay. Strain rosettes are used to rosettes ಅಂದ್ರೆ ಏನು? ಎಷ್ಟು ಜನರಿಗೆ ಕನ್ನಡ ಬರಂಗಿಲ್ಲ? How many of you don't know Kannada?
Strain rosette is used for measuring of strain.
Very good. Measuring of.
Elongation of elongations are there in strain.
But here
Used
they
for
have
that.
asked many strains, no? Shear strain, volumetric strain, linear strain, relief strain.
Only it shows the
Linear.
strain, sir.
Correct answer. Okay, it shows the linear strain. Rosette andre ಏನು ಗೊತ್ತಾ? Rosette means it is a advanced versions of dial gauge. Okay, dial gauge ಒಳಗಡೆ there will be needle and it will be rotating. Rosette means it will be having some electronic device. It will measure the strain. Okay. Next, a bar of L meter extends by L mm under a tensile force P. The strain produced in the bar.
D, sir.
D option. Okay, we'll see.
Yes.
L mm per L meter. Okay, mm you convert or this one you convert, whichever. This is 1 mm by 1000 mm. Okay, therefore it is the D is the correct answer. 1 by 1000 or 0.001 by 1. Now, the extension of bar tapered uniformly from D1 and ends D2. Direct you can see. See, I will give you one hint to remember this formula. Look at here. PL by AE. Okay? PL by E. A ಅಂದ್ರೇನು? Pi by 4 into D square. This 4 will come and sit here. Correct? Then this is a 4PL by pi D square E. This is for square bar, circular bar. Okay. If it is a tapered circular, then this D becomes D1, D2. 4PL by pi D1, D2 E. Okay. Easy to remember. Now, which option?
C.
C option. Next, the bar. The bar extension of a circular bar, the extension of circular bar tapered uniformly from D1 at one end and D2 at the other end. The subjected to an axial pull of P is dash extension of the circular bar of diameter D1, D2 subjected to the same load P. ತಿಳಿದು? No. Now, just understand the problem. You will answer that. Okay, I will not answer. The problem is
Equal to.
equal to, very good. Okay, the problem is like this, D2, D1. Another one is like this. This diameter is root D1, D2. Okay, this answer is 4PL by pi D1, D2 E. Correct? This answer is 4PL by pi D square E. D square means this one. Therefore, 4PL by pi. D square means d1 d2 whole root square cancel, therefore d1 d2 e. This and this both look same, therefore equal to. Okay, the ultimate tensile stress for mild steel is dash the ultimate compressive stress. See here, you have to
More
always
than C option.
C option, we'll see. Now look at here, this is a stress strain curve for mild steel. Mild steel in tension, mild steel in tension. Okay, if I draw the stress strain curve for mild steel in compression, hingogi, hingogi, hingogi. Okay, it will go up like this. Therefore, ultimate load for compression will be more than the tension. Okay, which option? Tensile stress of the mild steel is more than the ultimate compression. No, less than a ultimate tensile stress for mild steel is less than the ultimate compressive stress. ಇದು ನೋಡ್ಬೇಕು. ಇಲ್ಲ, ಇದು ಕರೆಕ್ಟ್ ಐತಿ. ಸಾರಿ, ಇದು ಟೆನ್ಸೈಲ್ ಕೆಳಗೆ ಬರ್ತೈತಿ, ಅಲ್ಲ ಟೆನ್ಸೈಲ್ ಮೇಲೆ ಹೋಗ್ತೈತಿ. ಓಕೆ, ದೆನ್ ಕಂಪ್ರೆಷನ್ ಹಿಂಗೆ ಬರ್ತೈತಿ. ದಿಸ್ ಈಸ್ ಕಂಪ್ರೆಷನ್ and this is tension. Okay, but both Young's model same, only ultimate ಒಳಗಡೆ change ಆಗ್ತದೆ. Therefore C option is the correct. More than. Maximum stress produced in the bar of tapering section is at
Smaller end of the bar.
smaller end, correct, because area is small, stress is more. P by A, area is small, stress is more. Okay, small. Modular ratio of the two material is the ratio of modular means modulus usually elastic modulus. Therefore there
Shear stress to shear strain.
no, not shear stress. Shear stress, shear strain is shear modulus. They have not asked this one. Their modulus rigidity is no G Allah, and this is wrong, this is correct. ಇಲ್ಲಿ ಬರ್ಕೊಂಬಿಡು. Modular ratio is nothing but M is equal to E1 by E2. This is the equation for modular ratio. Then shear modulus of most material with respect to modulus of elasticity is
Less than.
shear modulus of the material, most of the material less than, but ಇಲ್ಲಿ ಎರಡು ಅದವನ ಆಪ್ಷನ್ ಇಲ್ಲ. Less than half, more than ತೆಗೆದುಬಿಡು, equal ತೆಗಿ, none of it. No, we'll analyze this. Now they are asking the relation between E and G. Therefore we have equation E equal to 2G into 1 plus mu. Okay. Mu can be 0 and mu can be 0.5. In between mu can be 0.25. Correct? Now if I substitute mu equal to 0, then E equal to 2G. Which is bigger? E is bigger than G. Okay, if I substitute 0.5, E equal to 2G into 1 plus 0.5 is 1.5. 1.5 ಅಂದ್ರೆ 3 by 2. 3 by 2, 2 cancel. 3 by 2. Therefore 3G. Then again E is greater than G. Okay, now then 0.5 is okay, no problem. In both the case, E is greater than G. Therefore, the shear modulus of the material, shear modulus they are asking, therefore it is less than the E. Less than, we have only one option, less than half, it's okay, no. Because here, half, this is half, this is 1/3. Therefore, this is the correct answer. Let's say into one the option, no need to think. 33. A rod is enclosed centrally in the tube and the assembly is tightened by rigid washer. If the assembly is subjected to compression load, then ಇದು ಕಾಂಪೌಂಡ್ ಬಾರ್ಸ್ ಇದು ಇದು ಕಾಂಪೌಂಡ್ ಬಾರ್ಸ್ ಏನಂತೆ this is a one bar and another bar is there inside, correct? Now these two are rigidly washers na apply ಮಾಡಿದ್ರು. Two rods enclosed central in tube and assembly is tightened by rigid washer. If the assembly is subjected to compression, then the rod is under compression, the tube is under compression, the rod, the both tube and rod are in compression, tube is under tension and rod is under compression. Both ತೆಗೆದುಕೋಬೇಕು. Okay, it's nothing but tightening the nut and bolt. ಇದನ್ನು ಕೇಳ್ಯಾರ ಭಾಳ ಸತಿ question. Okay, see here, if this is a plate, okay, and here this one rivet is there. Now if I rotate this this one with pana, then this material, inside material will be in compression and the nut will be in tension. Remember this one, ಕೇಳ್ತಾರೆ. Nut will be in tension while tightening and the material is in compression. Okay, both compression ಅಂತ ಆಗಕ್ಕೆ ಸಾಧ್ಯ. Therefore both rod and tube is compression, wrong. Okay, here in this case and in this case you just remember the material here and the outer shell both are same, rod and nut are same. Therefore tube is under tension andra rod is under this one tube is under tension, ulta the rod is under compression. Or 30, which one is the right answer? ಇಲ್ಲಿ ಎರಡು ಆಪ್ಷನ್ ಕೊಟ್ಟಾನ, ಇದನ್ನೊಂದು ಇದೊಂದು, ಎರಡು ಬೇರೆ ಬೇರೆ ಕೊಟ್ಟಾನ, ಬೇರೆ ಬೇರೆ ಕೊಡಬಾರ್ದು. ರಾಡ್ ಇಸ್ ಅಂಡರ್ ಕಂಪ್ರೆಷನ್, ಟ್ಯೂಬ್ ಇಸ್ ಅಂಡರ್ ಕಂಪ್ರೆಷನ್. ಓಕೆ, then rod is under compression, tension, rod is under tension, no. Therefore we'll take this one alternatively, the tube is under tension, rod is under compression. Answer ತಪ್ಪು ಕೊಟ್ಟನವ, ಬೇಡ. The bolt, the bolt is made to pass through a tube and both of them are tightly fitted with the help of washers and nuts. The nut is tightened, then ಈಗ ಹೇಳಿದ್ದೆ
C, sir.
see, bolt is under tension, tube is under compression. Okay, bolt is under tension and tube is under compression. Tube ಅಂದ್ರೆ ಇಲ್ಲಿದೆ. Next, when the bar is subjected to change of temperature and its deformation is prevented, then the stress induced in the bar is, very interesting.
B, sir.
B. Okay.
Thermal stress.
The change temperature, deformation is prevented. The bar is subjected to change of temperature and its deformation is prevented. then the stress ತಪ್ಪಿದೆ ಕ್ವಶನ್ ತಪ್ಪಿತ್ತು. ಬರೀ ಚೇಂಜ್ ಇನ್ ಟೆಂಪರೇಚರ್ ಹೇಳೇನೋ, ಇನ್ಕ್ರೀಸ್ ಇನ್ ಟೆಂಪರೇಚರ್ ಡಿಕ್ರೀಸ್ ಇನ್ ಟೆಂಪರೇಚರ್ ಹೇಳಕ್ ಬರಲ್ಲ. See here, if the temperature increases, bar want to expand, then material this support compresses. Andra temperature increases, material compression aketi. Temperature decrease adra material tension ಬರ್ತೈತಿ. ಅರ್ಥಾಯ್ತಾ? ಐತಿ, ಕ್ವಶನ್ ಕರೆಕ್ಟ್ ಐತಿ. ಅಂದ್ರೆ ನಾ ಏನ್ ಮಾಡ್ಬಿಡೋದು, ಇದನ್ನು ಅಪ್ಲೈ ಮಾಡ್ಬಿಡೋದು, ಇದನ್ನು ಅಪ್ಲೈ ಮಾಡ್ಬಿಡೋದು, because of a change in temperature. Therefore thermal stress ಅಂತೂ ಸುಮ್ಮ ರ್ಯಾಂಡಮ್ ಆಗಿ ಆನ್ಸರ್ ಮಾಡಬೇಕು, ಶಿಯರ್ ಅಂತೂ ಬರಂಗಿಲ್ಲ. ಏನೇ ಡೌಟ್? ಕಳ್ರ ಇರ್ತಾರ ಅವರು, ಹುಷಾರಿರ್ಬೇಕು. The steel bar of 5 mm is heated from 15 degree to 40 degree and it is free to expand. The bar will induce, ಯಾರು ಹೇಳ್ತಾರೆ?
No stress. Stresses is not developed.
Very good. No stress.
But free end stresses.
Correct. Their free end is there. That's why free to expand is there. Therefore, no stress. Okay. Now I will change the question. Fixed. Now, which option?
Compressive stress.
Very good. Compressive stress. Because rigid and it want to extend, expand, but the supports are not allowing to expand. The bar is cooled to -5 degree. It will develop. ಇಲ್ಲಿ they have not mentioned any rigidity ಹೇಳಿಲ್ಲ. Therefore this is a wrong question. But ಆದ್ರೂ ಹೇಳ್ತೀನಿ ಅಂತಂದ್ರೆ ನೀವು ಅಸ್ಯೂಮ್ ಮಾಡ್ಕೊಂಡು ಯಾವ್ದು ಹೇಳ್ಬೋದು. Bar is cooled.
Tensile.
You can consider tensile because the bar is fixed minus degree model ಅಂತ ಅನ್ಕೋಬಹುದು. The bar of copper and steel from composite system which is heated to a temperature 40 degrees centigrade, the stress induced in the bar, copper bar, will be interesting.
Compressive.
Okay. Compressive. The bar of copper and steel from the composite which is heated, the stress induced in the copper. Okay, ಹೆಂಗೆ ಹೇಳಿದ್ರಿ?
Sir, copper value is about more than steel. That's the reason copper is extended more compared to steel. It regains its original position. That's the reason copper is compressive.
Very good. Correct answer. Correct explanation too. That is compression. The copper and let us consider this is a steel, and this want to extend more, and this will extend very less, but both will come in that compromise. They will compromise with one length. Then it has to compromise. It has to compress and it has to expand. Copper and steel. Therefore, this will be compression. Always remember, alpha value more means in these two, in when two materials are combined, if alpha 1 is greater than alpha 2, then alpha 1 will subject to compression when temperature increases. Okay. Then vice versa. Next, the thermal stress in the bar is dash proportional to the change in temperature. Temperature stress sigma is equal to L alpha T. Alpha TE. Alpha TE. Correct? Now, thermal stress in the bar is directly proportional to the change in temperature. Okay. Thermal stress dash upon the cross sectional area of the bar. ಇದೇ equation ನೋಡಿ ಹೇಳೋದು. Sigma is equal to alpha TE is independent, does not depend on cross section. Depend ಅಂತ ಇಲ್ಲ, ಇದರೊಳಗಡೆ A ಇಲ್ಲ ಲೆಂತ್ ಇಲ್ಲ, therefore no. If there is a fall in temperature of composite body, then the members having greater coefficient of linear expansion will be subjected to compressive stress. True. Thermal or temperature stress is a function of increase in function. Correct. Alpha TE is the answer. Increase in temperature, right? Modulus of elasticity, right? Coefficient of linear expansion.
Yes.
No. Coefficient of linear expansion, alpha, right? Therefore all the above right. When the circular tapering bar from D1 to D2 end and increase the temperature is illa idu paper 2 kodkodri. Okay, temperature stress bad idralage idu ಸ್ವಲ್ಪ derive ಮಾಡಂತೆ ಆಮೇಲೆ. Which of the following statement is correct? Which of the following statement is correct? The stress is the pressure per unit area. Wrong. Strain is expressed in mm. Wrong.
Sir, option D, sir.
D.
D. Hooke's law holds good up to breaking point. Deformation of the bar per unit length in the direction of force is known as. In the direction.
So volumetric.
No. In the direction of force. Unit length. Length ಅಂದ್ಮೇಲೆ ವಾಲ್ಯೂಮ್ ಬರಂಗೇ ಇಲ್ಲ. ಇದು ಬರಂಗೇ ಇಲ್ಲ. We have two options. In the direction of force, linear. Perpendicular to the direction of force, lateral. Every direct stress is always accompanied by strain in its own direction and opposite kind of strain in every direction at a right angle to it. Such strain is known as lateral strain.
Yes, sir. B.
The ratio of lateral strain to the linear strain is called Poisson's ratio. Poisson's ratio is the ratio. Poisson's ratio is the ratio of linear strain to the volumetric strain. False. Okay. This problem we can do. Poisson's ratio of the steel material varies from.
Point 0.23, 0.27.
This is also not there. 0.23, correct. Okay, ಇದು ಭಾಳ ಆಯ್ತದೆ. 0.33 soil ಆಯ್ತದೆ. Poisson's ratio for cast iron.
0.25, 0.33.
Very good. Then cast iron and mild steel, which is more brittle?
Cast iron is more brittle.
Very good. Why?
Its carbon content is more.
Very good. Correct answer. Carbon content is more in cast iron, therefore that is more brittle. Means carbon content as you increase, then brittleness will increase. When the bar of length L with width B and thickness T subjected to pull of P,
C option.
correct answer. Okay. Length increases, other two decreases. Ratio of change in volume to the original volume is called.
Volumetric strain.
Correct. Bar of length L B thickness T subjected to push of P. Length decreases, other two increases. Correct. Volumetric strain is the ratio of agate. Next, this one. When a rectangular bar of L breadth B thickness T subjected to an axial pull of P, the linear strain is given by.
Option A.
Option A. Correct answer. ಹೆಂಗ್ ಬಂತು?
Derive ಮಾಡಿದ್ರೆ ಬರುತ್ತೆ ಸರ್.
ಡಿರೈವ್ ಮಾಡಿದ್ರಿ? ಕರೆಕ್ಟ್.
Thickness
ಓಕೆ.
thickness ತಗೋಬೇಕು.
ಅಂದ್ರೆ ಅದರ್ ಟು ಡೈರೆಕ್ಷನ್ ಸ್ಟ್ರೇನ್ ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡ್ಕೋಬೇಕು. The rectangular LB thickness is subjected to an axial pull.
ಎಲ್ಲ Yes, sir.
Next, when rectangular bar of LBT subjected to an axial pull P, volumetric strain.
Bulk model.
Epsilon by epsilon Z. P ಇದ್ದಲ್ಲಿ ಎಷ್ಟು ಎಲಾಂಗೇಟ್ ಆಗ್ತದ ಅದರ್ ಟು ಡೈರೆಕ್ಷನ್ ಒಳಗಡೆ? ಡಿರೈವ್ ಮಾಡೋದು. One by m means mu it is. Strain into 1 minus 2 mu is a correct answer. The body is subjected to 3 mutual perpendicular stresses, equal intensity. The ratio of direct stress to the corresponding volumetric strain is bulk modulus. The relation between Young's modulus E and bulk modulus K is given by m ಒಳಗೆ ಕೊಟ್ಟನವ ನಮಗೇನು ಗೊತ್ತದ E equal to 3K into 1 minus 2 mu. Okay, we know that 3K into 1 minus 2 by m. m ಈ ಕಡೆ ಬಂದ್ರೆ m minus 2 by m is 3K. Correct? M minus 2 by m. This is your E. The and bulk modulus K is given by K. I want K is equal to E by 3. There is E by 3. E by 3 into m by m minus 2. Any option? 3 went inside. K equal to, this is the answer, D option. The ratio of bulk modulus to the Young's modulus for the Poisson's ratio 0.25. The ratio of bulk modulus to the Young's modulus, then E equal to 3K into 1 minus 2 mu. Mu is how much? 0.25. 0.25 into 2, 0.5. 1 minus 0.5, 0.5. 3 into 0.5, 1.5. K equal to L is answer 3 by 2. The ratio, 1 minute. The ratio of bulk modulus to Young's modulus, ಅಂದ್ರೆ K by E. K by E is equal to 2 by 3. Right? You can do this one. 9 kg, 64 question. C, they are using C. 9 kc, this is the correct answer. The ratio of shear modulus to the modulus of elasticity is Poisson's ratio 0.4. Okay. E equal to 2G 1 plus mu. Mu is 0.8. 0.8 plus 1, 1.8. 1.8 into 2, 3.6. Then G by E is equal to 1 by 3.6. 1 by 3.6. ಯಾವ ಆಪ್ಷನ್ ಬರ್ತದೆ ನೋಡ್ಕೋ. ಸರಿ 1.4 ಹಾಕಿತ್ತು. This is 1 plus 0.4, 1.4, 1.4 into 2, 14 28, 2.8, 1 by 2.8. 1 by 2.8, I think 7 by 5 or 5 by 7. Okay, no? Okay. There are many questions, you can solve them. If you have any doubt, just put a screenshot. Other the screenshot tagondo put in the group. Either I will answer. If anyone knows, they will answer. Okay. Anything you deserve? Again, fast ato, slow aito, theory beko, bado, ಏನರ comments ಇದ್ರೆ comments ಮಾಡ್ರಿ. So that ನಾಳೆಗೆ ನಾ improve ಮಾಡ್ಕೋಬಹುದು. ಫ್ಲೋ ಕರೆಕ್ಟ್ ಇತ್ತಾ? ನೀನು ಫಾಸ್ಟ್ ಮಾಡಬೇಕಾ, ಸ್ಲೋ ಮಾಡಬೇಕಾ? ಪ್ರಾಬ್ಲಮ್ಸ್ ಕರೆಕ್ಟಾಗಿ ಸಾಲ್ವ್ ಆದ್ವಾ? ಅಥವಾ ಪ್ರಾಬ್ಲಮ್ಸ್ ಜಾಸ್ತಿ ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಬೇಕಾ, ಥಿಯರಿ ಜಾಸ್ತಿ ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಬೇಕಾ? ನೋ ಕ್ವರೀಸ್? ಲ್ಯಾಂಗ್ವೇಜ್ ಕನ್ನಡ ಬೇಕಾ, ಇಂಗ್ಲಿಷ್ ಬೇಕಾ?
ಸರ್ ಎರಡೂ ನಡೀತಾವೆ.
ನಡೀತದೆ. ಓಕೆ, right. Okay, now you can end the meeting. There are many questions, 300-400 questions ಅದವ. ಅದರೊಳಗಡೆ ಎಲಾಸ್ಟಿಕ್ ಕಾನ್ಸ್ಟೆನ್ಸಿ ರಿಲೇಟೆಡ್ ಇದ್ದಿದ್ದು ಐ ಥಿಂಕ್ 100-150 ತನಕ ಬರ್ಬೋದು. ಯು ಕ್ಯಾನ್ ಗೋ ಥ್ರೂ ದಟ್ ಒನ್. ಯಾರು ರಿಯಲ್ ಟೈಮ್? ಸರ್, ವಿಲ್ ಯು ಪ್ಲೀಸ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ದ ರಿಯಲ್ ಟೈಮ್ ಎಕ್ಸಾಂಪಲ್ಸ್? ರಿಯಲ್ ಟೈಮ್ ಎಕ್ಸಾಂಪಲ್ಸ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಕ್ಕೆ 2 ತಿಂಗಳೈತಪ್ಪ. ಹೌದಾ? ರಿಯಲ್ ಟೈಮ್ ಮಾಡಕ್ಕೆ ನಾ ಭಾಳ ಖುಷಿ ಪಡ್ತೀನಿ. ಬಟ್ 2 ತಿಂಗಳದೊಳಗೆ ಎಲ್ಲ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ತಗೊಂಡು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಕ್ ಆಗಂಗಿಲ್ಲ. ಈಗ ನಾವು ಹೆಂಗ್ ಮಾಡ್ಬೇಕು ಗೊತ್ತಾ? 2 months ಅದ ಅಂದ್ರೆ ನೀವು ಬರೀ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ಬೇಕು, ಮಗ್ಗಪ್ ಹಾಕ್ಬೇಕು, ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ಬೇಕು, ಮಗ್ಗಪ್ ಹಾಕ್ಬೇಕು. ಏನಾರ ಮಾಡಿ ಪ್ರಿಲಿಮ್ಸ್ ಪಾಸ್ ಆಗ್ಬೇಕು. ಮೇನ್ಸಿಗೆ ಬರ್ತಿರಲ್ಲ, ಅವಾಗ ನಾ ನಿಮ್ಗೆ ರಿಯಲ್ ಟೈಮ್ನೇ ಹೇಳ್ಬೇಕಾಗ್ತೈತಿ. ಸಿಯರ್ ಪೇಪರ್ 2 ಈಸ್ ಆಲ್ವೇಸ್ ಲೈಕ್ ರಿಯಲ್ ಟೈಮ್ ಪ್ರಾಬ್ಲಮ್ಸ್. ಅಲ್ಲಿ ನಿಮ್ಗೆ ಬೇಕು ಪೇಪರ್ 2 ಒಳಗೆ. ಪೇಪರ್ 1 ಹೆಂಗಾರ ಮಾಡಿ ನೀವು ಪಾಸ್ ಆಗ್ಬೇಕು. ಓಕೆ, ಅಂಡ್ ಒನ್ ಮೋರ್ ಥಿಂಗ್, ನೀವು ನೋಟಿಫಿಕೇಶನ್ ಸ್ವಲ್ಪ ಚೆನ್ನಾಗಿ ಓದಿದ್ರೆ ಭಾಳ ಇಂಪಾರ್ಟೆಂಟ್ ಅದ ನೋಡಿ, ಕೇಳ್ರಿ. ನೋಟಿಫಿಕೇಶನ್ ತೋರಿಸ್ತೀನಿ ನಿಮ್ಗೆ ಒಂದು ಸ್ವಲ್ಪ. ಏನು ಅರ್ಜೆಂಟ್ ಇಲ್ಲಲ್ಲ?
No, sir.
ನೋ, ಆನ್ಲೈನ್ ನ್ಯೂಸ್ ಕಾಣ್ತೈತಿ. ಇಲ್ಲಿ ಕಟ್ ಆಫ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು. ಆಮೇಲೆ ಇದು ನೋಡಿ, ಮೋಡ್ ಆಫ್ ಸ್ಕೀಮ್. Minimum qualifying marks in paper 1 and paper 2 are as follows. Unreserved 30%, OBC EWS 25%, all other category 20%. Based on the normalized marks in paper 1, computer based examination, candidates will shortlisted category wise to the paper 2. This is very important. Based on the normalized marks will be there when 2 sessions are conducted. Okay, candidates will be shortlisted category wise to appear paper 2. paper 2 appear ಆಗಲಿಕ್ಕೆ ನಿಮಗೆ ರ್ಯಾಂಕ್ ಲಿಸ್ಟ್ ತೆಗೆಯಂಗಿಲ್ಲ ಅವರು. ಇಷ್ಟು ಪಾಸ್ ಆದ್ರೆ ಮುಗಿದು ನಿಮ್ದು ಪೇಪರ್ ಲಿಸ್ಟ್, ಇದ್ರೊಳಗೆ ಪೇಪರ್ 2 ಎಲಿಜಿಬಲ್ ಆಗಿಬಿಡ್ತೀರಿ. ಅನ್ರಿಸರ್ವ್ಡ್ ಎಷ್ಟಿದೆ? ನೀವು ಅನ್ರಿಸರ್ವ್ಡ್ 30% ಅಂದ್ರೆ 200 ಮಾರ್ಕ್ಸಿಗೆ ಎಷ್ಟು? ಇಫ್ ಯು ಸ್ಕೋರ್ ಮೋರ್ ದನ್ 60 ಔಟ್ ಆಫ್ 200 ವಿತ್ ಕನ್ಸಿಡರಿಂಗ್ ನೆಗೆಟಿವ್ ಮಾರ್ಕ್ಸ್, ನೀವು ಎಲಿಜಿಬಲ್ ಆಗಿಬಿಡ್ತೀರಿ ಪೇಪರ್ 2ಕ. ಪೇಪರ್ 1 ಮುಗಿದು ರಿಸಲ್ಟ್ ಬಂದು ಪೇಪರ್ 2ಗೆ ಇನ್ನೊಂದು 2 ತಿಂಗಳು ಟೈಮ್ ಇರ್ತೈತಿ. ಇನ್ನು 2 ತಿಂಗಳ ಟೈಮ್ದೊಳಗಡೆ, ಆ ಟೈಮ್ನೊಳಗೆ ವೆಂಕನಗೌಡ್ರೆ ಬೇಕಾದ್ರೆ ನಾವೇನು ಮಾಡ್ಬೋದು, ಪ್ರಾಕ್ಟಿಕಲ್ದನ್ನು ಮಾಡ್ಕೋಬೋದು. ಓಕೆ, ಅವಾಗ ಪ್ರಾಕ್ಟಿಕಲಿ ಮಾಡೋಣ. ನೀವು ಪೇಪರ್ 1 ಪಾಸ್ ಆದ್ರಿ ಅಂತಂದ್ರೆ ನಿಮ್ಗೆ ಬಾಗಲಕೋಟೆಗೆ ಕರೆಸಿಬಿಡ್ತೀನಿ. ಇಲ್ಲೇ ಆಫ್ಲೈನ್ ಮಾಡಿಬಿಡ್ತೀನಿ ರಾತ್ರಿ. ತಿಳಿತಾ? ಹೆಂಗಾರ ಮಾಡಿ ಪೇಪರ್ 1 ಪಾಸ್ ಮಾಡಿಕೊಡ್ರಿ. ಓಕೆ 30% ದಾಟ್ಬೇಕು ನೋಡಿ, ಅಂದರೆ 60 ಒಂದು 80 ಮಾರ್ಕ್ಸ್ ದಾಟಿಸಿ ಬಿಡ್ರಿ ಆಗಿಬಿಡ್ತದೆ. ಫಾರ್ ಅಪ್ಲಿಕೇಶನ್ಸ್, ಓಕೆ ಇಟ್ಸ್ ಓಕೆ ಸರ್. ಫಾರ್ ಅಪ್ಲಿಕೇಶನ್ಸ್ ವಿ ನೀಡ್ PDC of our degree but still we are not getting. VTU ಹೋದ್ರೆ ಕೊಟ್ಬಿಡ್ತಾರೆ, ರಿಸಲ್ಟ್ ಬಂದು ಮರ್ದಿನ ಕೊಡ್ತಾರೆ. PDC ರಿಸಲ್ಟ್ ಬಂದದ ನಮ್ಮೋಕರ್ ಬಂದದಿಲ್ಲ. VTU ಹೋಗಿ ಒಂದು ಅಪ್ಲಿಕೇಶನ್ ಬೆಳಗ್ಗೆ ಕೊಟ್ಟರೆ ಸಾಯಂಕಾಲ ಕೊಟ್ಬಿಡ್ತಾರೆ PDC. ಅದನ್ನೇನು ಭಾಳ ಡಿಲೇ ಮಾಡಂಗಿಲ್ಲ. ಈಗ ಅಪ್ಲೈ ಮಾಡಕ್ ಬೇಕಿತ್ತಂದ್ರೆ ಮತ್ತೆ ನಾಳೆ ಹೋಗ್ಬೇಕು, ನೀವು ನಾಳೆ ಹೋಗಿ ತಗೊಂಡ್ಬಿಡ್ರಿ. ಎನಿ ಅದರ್ ಡೌಟ್ಸ್? ಓಕೆ, ಏನು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ, ಏನು ಡೌಟ್ಸ್ ಇಲ್ಲ. ಓಕೆ, ದ ಫಸ್ಟ್ ಡೇ ಈಸ್ ಕಂಪ್ಲೀಟೆಡ್. ಇಫ್ ಯು ಆರ್ ಇಂಟ್ರೆಸ್ಟೆಡ್ ಟು ಮತ್ತಿನ್ನು ಫರ್ದರ್ ಕಂಟಿನ್ಯೂ ಮಾಡ್ಬೇಕಿತ್ತಂದ್ರೆ 500 rupees ಪೇ ಮಾಡಿಬಿಡ್ರಿ. ನಂದು ಸೇಮ್ ಮೊಬೈಲ್ ನಂಬರನ್ನೇ ಫೋನ್ಪೇ ಅದ. ಇಲ್ಲ ಸರ್ ನಾ ಇನ್ನೊಂದು 2 ಲೆಕ್ಚರ್ ಡೆಮೋ ನೋಡ್ತೀನಿ ಅಂದ್ರೆ ಮೆಸೇಜ್ ಮಾಡ್ರಿ ನನಗೆ, ಸರ್ ನನಗೆ ಇನ್ನೊಂದು 2 ಲೆಕ್ಚರ್ ಡೆಮೋ ನೋಡ್ತೀನಿ ಅಂತ. ಯಾಕಂದರೆ ನಾವು ಆ ಗ್ರೂಪಲ್ಲಿ ಫೀ ಪೇ ಮಾಡಿದಾರನ್ನಷ್ಟೇ ಇಟ್ಕೊಂಡು ಉಳಿದಾರನ್ನೆಲ್ಲ ತೆಗೆದು ಬಿಡ್ತೀವಿ. ಓಕೆ, ದಟ್ಸ್ ವೈ ನಿಮ್ದು ಏನಾದರೂ ಡಿಲೇ ಮಾಡೋದಿತ್ತು ಹಂಗೇನಾರ ಇತ್ತಂದರೆ ಹೇಳ್ರಿ, ಸರ್ ನಮ್ಗೆ ಆಗಂಗಿಲ್ಲ, ಇನ್ನೊಂದು ವಾರ ಟೈಮ್ ಕೊಡ್ರಿ, 4 ದಿನ ಟೈಮ್ ಕೊಡ್ರಿ, 3 ದಿನ ಟೈಮ್ ಕೊಡ್ರಿ ಅಂತ. ಬಟ್ ನಾಟ್ ಮೋರ್ ದ್ಯಾನ್ 1 week. ರೈಟಾ? ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್. ಆಲ್ ದ ಬೆಸ್ಟ್. ಗುಡ್ ನೈಟ್. ಏನಾಯ್ತು ನಿತಿನ್? ಹೋದ್ನ?